Hi folks, and welcome to my demo of WebGL. This is the first look of my learning towards WebGL and its contents. This will only cover very basic items of creating a code structure. What all does it cover? We'll be creating these objects, texture as well as color. As usual, recommended browser would be 11. This code also contains a good proper console log, which I'll show you where all it's written so that you can debug errors. The primary intention of the code as well is to not only create but to correctly destroy, so it also disposes correctly. The reason for using I11 would be the memory profiler, which I have tested, and though this does not leak anything, it would be the best first go at knowing WebGL. I11 supports WebGL. Two websites which I would recommend you to look at beforehand a little bit would be Learning WebGL, which was my base, as well as the MSDN library of the active WebGL APIs. Now before we jump into anything of WebGL, the two items that you would need would be GL matrix 2.0 latest ones. Okay, I have extracted it like this. You can use the main version. The reason for extracting like this, I wanted to see what is inside the code. There has been no modification of the code within GL matrix. I am not using the old GL matrix 0.95. Also, I need WebGL utils from Ruby. The reason for using the same would be there is a ready-made function called you can initiate the WebGL without doing much. So it already takes care of creating the context. All I need to do is call setup WebGL. It also creates a web page where if the page does not the browser does not support GL, for example like Safari, it will already display something like this. Okay, now getting into it. This is an image that is being used. There is a reason why I put these lines, which will come in the later chapters, is to find interpolation or something. To begin with the code, let's talk a little bit about camera, this part. Okay, so there is no real perspective within whenever you think about rendering, you'll think there's a camera and then there is something else rendering. Well, here there is no actual aspect like camera. The star that I have put over here, let's assume that as a camera location. That is actually a base that is from 0, 0. Say this is a circle and there is a depth, and this would be 0, 0. This inside would be depth. Okay, and assume this is a star. What we are going to do is, while rendering all these elements, the square, triangle, we are going to give it a -z so that it goes inside. Okay, hopefully you remember some transposition maths like this, that is for rotation and transposition, but the thing is these all are taken care of by GL matrix, so you don't need to remember all of them. Next is GPU. Something you need to learn about normal rendering is, see that the red is put behind and blue is first, so first render goes back, second render comes front. Next, the thing about the code structure would be, it's a pocket. We have a browser that is rendered here, come to here, we have a browser that is rendered. So the idea is we have created a base pocket, okay, and a GL base pocket. The GL base pocket contains the rendering, that is the basic GL trigger initialized. It doesn't work like canvas where you put as context 2D. Context 3D is not present, so I had to move to WebGL. So GL base pocket will contain the base WebGL code initialized, okay, and the pocket will contain all the necessary GL codes that has been initialized. You need to write a little too much just to initialize WebGL. After that, we'll insert array style of pockets. So what we'll do is, once the base pocket is initialized, we need to put a triangle within a pocket. So that is to render a triangle like over here. So this pocket will be running. GL has already been initialized. So you'll put a triangle first, square next. We can dump. I have created a specific array to do that. The actual way of doing it is having a threaded triangle, a threaded square. As of now, I have not done that, and I am not aware if it is feasible. If it is feasible, then please do specify in the comments on how that can be done. I need to create a threaded triangle. As of now, this is an array in which whichever it will keep on looping redraw. That means it will keep on drawing on the WebGL screen till this array ends. So if you insert only triangle, triangle keeps on rendering. I keep square, it's in a redraw functionality. It works the same way. Next, the two line items that you need to remember is in a shader. Okay, there is two types, fragment and vertex shader. One contains the position attribute, one contains the color and R texture on. Okay, and GPU contains two aspects within means there are two aspects when you learn about GPU. Once, the annoying thing is you need to buffer the items, that is you need to put it in the memory and then put, okay fine, this is the shader program, this is the program I want it to run. Then you need to tell it to, okay, now I have inserted this program, draw it. So each time you need to say which shader program to use. Since we are using an array loop, since we are using an array, each time you have to say use this shader program, render, use this shader program, render. So every time you have to do this buffering and redrawing. So buffer can be done once, draw needs to be done every single frames per second. The WebGL util already contains request anime frame to take care of that. So the minute you call request anime frame and then call a function, it will take care of it. Okay, so the four main aspects that would come into aspect would be vertex that we spoke about, color or texture that we spoke about, indices, I'll come to it. So everything within a WebGL is rendered by triangles. So if you want to draw a square, so you have to draw two triangles. This is how it's rendered. So you need to say like 0, 1, 2 and then 0, 1, 3, something like this. So you need to specify these indices. This will be used mostly in cube indices. The rest, vertex and color should suffice for drawing triangles, pyramids, because pyramids and all, everything is triangle. Everything is triangular rendering, remember that. Okay. Now after knowing all this, just keep it in your head. Coming back to the code. So WebGL utils has request anime frame. Remember that I had a button called stop render that I could stop it. So to do this I need cancel request anime frame that I have created inside a cross browser method of doing it. So this function works, you can use it anywhere else. Okay. So now what I have done is, instead of calling the old GL matrix, I have called the new matrix, and whatever I want it to run, means I wanted to know which exact line items are being used, and I called Google's WebGL utils. There has been no modification done within GL matrix and WebGL utils. The other aspect would be I created individual shaders for triangle, square, cube with texture, pyramid, so that each one I can store it within a separate program. So triangle will have the fragment shader contains what color, and this contains what is the position, and it will assign the vertex color over here. Okay, these are all CGL programs, and it will compile. Now coming to the base code, if you are already aware of my canvas, these are some basic line items that I take care of. Width, height variables, frame rate, mouse location. This is not used yet, the mouse code. Then object list to dispose is where the disposition will be taken place. Note that the whole pocket is only one object. The pocket itself contains, let me mark it with green. Whole pocket is one object. The object contains these arrays. So once I dispose pocket, it will automatically means I have written the code to dispose all this also. Fine. The square, whatever has been rendered. Fine. Redraw ID is used to cancel request anime frame. Whenever you request anime frame, there is a ID that is got by request anime frame. So you need the last ID to stop the rendering. That's why redraw ID. Looper printf is to print degree to radians conversion, frames per second code over here. Mouse objects location has been written here, not yet used. On exit, basically this would contain would be just the base pocket. Now coming to the WebGL. Now WebGL base pocket, what it contains is, it just uses setup WebGL, which is over here. Fine. So this code has been used, setup WebGL, and this will trigger initialize the WebGL. Canvas.width width and height of the canvas has been assimilated over here. Fine. So coming to the top, it starts with WebGL initialization. Any exception handling, else everything has been taken care of. If you find anything missing, please do put in the comments. Define WebGL. Now what you see is just that the GL has been initialized, nothing more than that. Now once that GL is initialized, as I specified in the diagram, there is a pocket, but there is a GL base pocket. Just now we saw the GL base pocket, and the define pocket is what defines the GL base pocket. If it works, that is everything is fine, I use black color in the background with alpha 1, okay, and enable depth. So next is I'll finish all the declarations. These are some temporary variables required. These are the contents of the pocket that I was talking about. And as a whole, the object list to dispose pocket itself will be in this. Once I trigger this dispose, it's going to trigger this list, which we'll see in soon. So as I said before, there is vertex and as I showed you, vertex and fragment. So you need to compile that, right? So get shader compiles that over here. This is the shader program compilation. Initialization shader is where you initialize the fragment and vertex shader, okay, and it will have a shader program which has compiled, or there is a code for color if it exists, or texture, whichever it is, it will create a shader program. Next, texture load, that is if you want texture or color to do, so do texture load. I'll pass in which texture I'm going to use to the image, and load texture, there is a flip done. The reason is this picture as it is, why it is appearing straight is because it is flipped. Why it is flipped? Example would be in MS Paint, you notice that the 0,0 starts from here and the highest number ends from here, but logically in a 2D diagram or in a 3D environment, 0,0 is here and the positive moves over here. So we need to flip it before. So this unpack flip is the reason why this is done. The whole idea of this is to trigger the texture with the filter mag and min. This we will see later on. Push matrix, pop matrix, generic functionality, where you remember there is a perspective. There is a perspective over here, the star. So the star will remain constant. It's not going to move. So we need to render this perspective right here. Remember, it's not an actual perspective. And then we need a move matrix, another matrix that pushes out the data to the depth area. Now so next is, this is the code for render perspective. The reason why it's working in 2.0, just a clue to folks who have doubts on that, is the reason of this point 1. Do not start it from 0. Animate is nothing but a rotatory animation. This is not a pure animate. Okay, so coming to buffer and draw, let me show you triangle. So what all it does, first it buffers the vertex and next it buffers the color. Okay, the reason of this 3 I'll explain. Item size is going to be columns and the number of items is going to be rows. The reason why it is 4 here is RGB, and then it is going to have alpha. The color declaration has been done over here, fill pocket. So triangle object will have RGB and then alpha. I have given enough comments at the bottom for it to be readable. So there is each individual code for drawing as well as buffering every single line item. Okay, while drawing also, what it does is it first translates the P matrix perspective. This is Z is depth. This is the only hard-coded element within the whole code. That is, I have manually set the X, Y and Z position of the P matrix. MV matrix is going to be the matrix of which where the content of the, that is example triangle, is rendered in this location. Okay. Draw triangle, then there is buffer square, draw square. Let me come to cube. Cube will have a little difference of having a I have written code for color and texture within the cube, so there will be a small difference within the cube. During buffer cube, the only difference, yes, one more thing, the size has been used, so you don't need to worry about this. All you need to do is, while declaring the, while calling fill pocket, you just give the size. Or the difference in buffer cube would be, it would not just call the vertex and buffer, means color, vertex, color and texture. It would also have an indice, and the reason is why I exactly told over here, 0, 1, 2 and 3. Next is draw cube, buffer pyramid, draw pyramid. The code should be very similar. Okay. Now Coming to redraw functionality, this functionality is called by call redraw. Call redraw is in turn called by fill means the initial trigger itself. I told you right in the MS pane where I'll call redraw and then I'll start filling the pocket with triangle, cube and pyramid and everything. So that's why I call redraw initially itself here and then I start filling the pocket. There is a reason why redraw is done first, so that you don't see any WebGL errors in the console log. So I wanted to test it personally, that's the only reason I've done it. And the color here again for each front face, right face comment is given on what type of color will be used, and go ahead and fill with that. Now coming to fill pocket. Fill pocket is the code where I need to specify what is the filler type and what is the size. These are some fixed items so that it's easier for deallocation. Okay. Now on triangle, when it comes to, I'll fill the triangle objects with content. Not many are used. Remember, 2 of them are not used as of now. Texture is not used for everything else. That's why I've written it like that. So here in triangle, I'm just filling the color. Here in the shader program, I'll trigger the shaders. Only for cube, like cube texture over here, I would be initializing the texture also. So all the base code is already ready made. All it needs to do is, so once I allocate that to the content list, you remember this is the content list. So I'm just filling it in the content list. This content list, same item has been done for pyramid, cube, everything, and this content list is used within Redraw. Fill content list at one, render. Note here, like I told before, you need to tell the GL to which shader program to use, otherwise it will not render correctly. I hope this was clear. Frames per second code is also inserted over here. Everything starts from main. Main has it will draw the canvas, that is it will declare the canvas. I have a button for render. Coming to destruction, what I have done over here is I'll loop through the content list and I'll destroy every single common variable, destroy the shaders, textures, all the destruction code is available here. Delete A, B, C, D, delete buffer, program, shader, texture. I've used all of these to check whether it's deleting correctly. Remember, I cannot confirm on that. I'm assuming it will do it right. So all the deletion is done, and then finally I'll destroy the pocket. This is also called on exit. So on exit, it's going to call the destroy also. I just created a button to demonstrate on how it works. Exit. So on exit is going to call the primary pocket destroy. That pocket destroy is what you are looking at right now, which in turn will destroy all the program contents and then exit of the tab or the browser. This is simply for a good programming practice. This is my first demo of WebGL and my own learning. Thank you for watching.